Hey everybody, this is Mrs. Hilt with your lecture on periodic trends. Please follow along with the lecture slides so you can fill in all of the blanks. And whenever you have a question, pause the puzzle and write it right on the slide that the question popped in your head. Then ask those questions when we return to class. All right, so here are the learning goals or the objectives for the lesson. So students will know the three trends on the periodic table, which is atomic radius, electronegativity, and ionization energy. And you'll be able to determine which element in a set will have a bigger or smaller atomic radius, higher or lower electronegativity, and higher or lower ionization energy, simply based on its location on the periodic table. All right, and we'll talk more about each one of these, but here are the definitions for each. Please pause the video, read through those definitions. When you're ready for more, press play. All right. So please have your periodic table available. So when we are marking the directions of increasing and decreasing atomic radius, electronegativity, and ionization energy, your periodic table is there to mark up. All right, we're starting with atomic radii. So as the principal quantum number n increases, so as you're going vertically down the periodic table, the size of the radius or size of the atom also increases because you're adding more energy levels, so you're increasing the distance from the nucleus to the very outside energy level. So therefore, as you move down a group, the atomic radius increases. Now, going horizontally on the periodic table across the periods, the atomic size actually decreases going left to right across a period. And remember that if elements are in the same period or same row on the periodic table, they have all of the same orbitals, the same shells, and therefore have the same energy. But as more protons are added going left to right, because the atomic number increases going left to right, the attraction from the electrons increases, pulling the electrons closer to the nucleus, resulting in a smaller radius. We can see that on this graph. So we have a group 1 element, lithium, and the noble gas that is in the same period. And as you go across the periodic table, the atomic radius decreases. So it's a little hard to see here. Going left to right, you have decreasing atomic radius, and going up down, you have increasing atomic radius. So here's an example of how it could look. Increasing atomic radius, increasing atomic radius. For this example, I switched the arrows just so that I could remember it as both increasing, going that way. All right, let's get some practice. So for each of these pairs, I want you to identify which will have a larger atomic radius. All right, let's check your answers. So we have potassium and lithium. So potassium, the K, will have a larger atomic radius than lithium because it is lower on the periodic table. Then we have bromine and potassium again will have a larger atomic radius because it is further left in the period than bromine is. Lastly, phosphorus and chlorine. Phosphorus will have a larger atomic radius because it is more left than chlorine in its period or energy level on the periodic table. So, one more time, double check your answers. All right, on to trends in ionic size. So, we know that there can be two different types of ions, cations that are positive and anions that are negative. When cations and anions are formed, this impacts the atomic radius because that means that there are gaining and losing of electrons occurring. When cations are formed, the atomic radius is actually smaller than the atom from which it was formed. For anions, the atomic radius will be larger than atoms from which they are formed. So the reasons why is when there are more protons, a cation, it is smaller because there are more positive charges in the nucleus pulling the electrons closer. When there are more electrons, so an anion, it is larger because there are less positive charge pulling those negative electrons close to the nucleus. So here's more examples. We have the atom. When it loses an electron, becomes positive, smaller radius. On the other end, we have an atom. Given an electron, becomes larger. All right, now let's get some practice with you guys identifying the larger atomic radius between the two groups. Or sorry, not the larger atomic radius. Which ones show the correct relationship? All right, let's check your answers. So, A is incorrect. The cation radius is smaller than the neutral atom, therefore it should be going the other direction. B, the anion radius is larger than a neutral atom, therefore this one should also be going the other direction. C, titanium is left of zinc on the periodic table, therefore titanium would have a larger atomic radius. D, the anion has a larger radius than the neutral atom, so this one is correct. Then the last one, sulfur is in a higher energy level than oxygen. They're both in the same group vertically, but because sulfur is further down or in a higher energy level on the periodic table, sulfur will have a larger radius, so that should also be switched. All right, now trends in ionization energy. So what ionization energy is the energy required to remove an electron from an atom. And this is always positive because it does take energy to remove an electron. Okay, so groups and periodic trends in ionization energy. So the first ionization energy decreases from the top to the bottom within a group and increases from left to right across the period. So notice this is the exact opposite of increasing atomic radius on the periodic table. So therefore, elements at the bottom of a group are more reactive than at the top. So how this would look. So arrow pointing down, we have decreasing ionization energy, and going left to right, we have increasing ionization energy. So if you want to mark up your periodic tables, I again switch the arrows just so that all arrows are pointing the same direction, and then all of the descriptions match up. So decreasing ionization energy, and at the same time you are increasing atomic radius. All right, again, let's get some practice, this time with ionization energy. So from each of these pairs, I want you to select which element has a higher ionization energy. All right, let's see how you guys did. So all of the answers will be the exact opposite. So therefore, potassium will not be the correct choice for either of the examples it's in. Lithium and bromine will be. And phosphorus and chlorine will have a higher ionization energy because it is further right on the periodic table. Here those answers are again. All right, now for electronegatividity. Here are all of the electronegativities of the elements on the periodic table. And here's a chart with all of the different color codings. So as you can see, fluorine is the most electronegative element. So fluorine, its ability to attract electrons towards itself to create a chemical bond, it's super, super reactive. And chlorine, oxygen, bromine, All those elements are very close to fluorine with its really, really high electronegativity. And these elements are actually elements that make up strong acids. So it makes sense that we have acids that are very strong, powerful, and the elements that make them up have very high electronegativities. Notice that the noble gases are not on this scale. So their shells are completely full of electrons, or their valence shell is completely full. So they don't want to bond with anything else. They don't want to share their electrons. Noble gases are thought of as the happy elements because they have all of the electrons they need and they are satisfied. So therefore, they do not have electronegativity values. All right, and here is the final chart. So all the arrows are pointing in the same direction. Atomic radius decreases going left to right, while electronegativity and ionization energy increases going left to right. Then going up, down, atomic radius increases where electronegativity decreases and ionization energy decreases. All right, let me know if you guys have any questions. Thanks for watching.